Hello students, today's session is especially for SSC class 10 students. The chapter we are covering here is from Science 1 Metallurgy. The intention of this video is to give you a quick revision of the given chapter. As you all might have seen that it's a little bit of lengthy chapter. So here is a series of videos which will cover the entire chapter and all the content from the chapter. So within a shorter span of time, you can have a thorough revision of the chapter. So let's get started. So the first part will cover physical and chemical properties of metals. So we start with physical properties of metals. So metals exist mainly in solid state. Again, the exception is there, that is mercury and gallium exist in the liquid state at room temperature. Metals are lustrous, ductile, and malleable. All metals are good conductors of heat and electricity. Generally, all metals are hard except the alkali metals from group 1, that is lithium, sodium, and potassium. Metals have high melting and boiling points. Exception: sodium, potassium, mercury, and gallium. Certain metals are sonorous, that is, they produce sound when struck. Now we start with chemical properties of metals. Metals are reactive. Metals are electropositive elements. They lose electrons easily and become positively charged ions. Hence, they are called as electropositive elements. Metals react with oxygen, water, dilute acid, nitric acid, both dilute as well as concentrated, and salts of other metals. Reaction with oxygen, which is also called as the combustion reaction. Metals combine with oxygen on heating in air and metal oxides are formed. That is, metal plus oxygen gives us metal oxide. The example is twice Mg plus O2 gives us twice MgO. Here magnesium is in the solid state, oxygen is in the gaseous state, and the product obtained, that is magnesium oxide, is in the solid state. Sodium, being highly reactive, combines with atmospheric oxygen even at room temperature. It readily catches fire. Therefore, to prevent accident in the laboratory or elsewhere, it is kept in kerosene. So the reaction of sodium with oxygen is 4 times sodium, 4 times Na plus O2 gives us twice Na2O. Oxides of some metals plus water gives us alkali. Therefore, some of the oxides or oxides of some metals are called as the alkali oxides. Examples: Na2O plus H2O gives us twice NaOH, which is sodium hydroxide and alkali. MgO plus H2O gives us MgOH twice, which is again an alkali, that is magnesium hydroxide. Next, we start discussion of reaction of metals with water. Now, these reactions, they are categorized as rapid and vigorous reaction with water, slow and less vigorous reaction with water, and reaction with steam, and no reaction with water. So, in case of rapid and vigorous reaction with water, the metals under consideration are sodium and potassium. Here, the general reaction is metal plus water gives us metal hydroxide plus hydrogen gas plus heat. That is, this reaction is an exothermic reaction. So the examples or the chemical equations of these reactions are twice Na plus twice H2O gives us twice NaOH plus H2 plus heat. Similarly, for potassium, the chemical equation is twice K plus twice H2O gives us twice KOH plus H2 plus heat. The next classification or the next type of reaction with water is slow and less vigorous reaction with water. Here, the metal under consideration is calcium. The general reaction is metal plus water gives us metal hydroxide plus hydrogen gas. The chemical equation for the same is twice Ca plus twice H2O gives us twice CaOH twice plus H2. In this particular reaction, calcium metal floats on water. Reason? Calcium reacts with water slowly and less vigorously. The hydrogen gas released in this reaction collects on the surface of the metal in the form of bubbles, thus causing calcium metal to float on water. Reaction with steam. The metals under consideration are aluminium, iron, and zinc. General equation is metal plus steam giving us metal oxide plus hydrogen gas. The balanced chemical equations are for aluminium 2 times Al or 2Al plus 3H2O giving us Al2O3 plus thrice H2. For iron 3Fe plus 4H2O giving us Fe3O4 plus 4H2. Zn plus H2O gives us ZnO plus H2. Please note the state of water or H2O here, which is gaseous state. That is, these metals, that is aluminium, iron, and zinc, they react with steam. There are certain metals which do not react with water, and those metals are gold, silver, and copper. The next type of reaction is reaction with dilute hydrochloric acid or dilute sulfuric acid. So metals like aluminium, magnesium, iron, or zinc react with dilute hydrochloric or sulfuric acid to give chloride or sulfate salts and hydrogen gas. The general reaction is metal plus dilute hydrochloric acid gives us metal chloride plus hydrogen gas. Similarly, metal plus dilute sulfuric acid gives us metal sulfate plus hydrogen gas. So the balanced chemical equations are Mg plus twice HCl gives you MgCl2 plus H2. 2Al plus 6HCl gives you 2 times AlCl3 plus thrice H2. Iron Fe plus twice HCl gives you FeCl2 plus H2. And for zinc, it is Zn plus HCl giving us, it should be twice HCl giving us ZnCl2 plus H2. Here, if we arrange the metals in the decreasing order of reactivity, we see that magnesium is the most reactive, than aluminium, than zinc, than iron. Reaction with nitric acid. So nitrate salts of metals are formed on reaction of metals with nitric acid. Here, the reaction is a little bit different than the reaction with hydrochloric or sulfuric acid. So nitrate salts of metals are formed on reaction of metals with nitric acid. Various oxides of nitrogen like N2O, NO, or NO2 are also formed in accordance with the concentration of nitric acid. Reaction of copper with concentrated nitric acid is as follows. Cu plus 4HNO3, which is the concentrated nitric acid, giving us CuNO3 twice plus twice NO2 plus twice H2O. Whereas reaction of copper with dilute sulfuric acid is 3 times Cu or 3Cu plus 8HNO3, that is dilute nitric acid, giving us CuNO3 twice plus twice NO plus 4H2O. So here oxides of nitrogen are differing. We obtain copper nitrate as one of the products, but oxides of nitrogen are different. Now we come to something called as Aquaria and their relationship with noble metals. Aquaria is freshly prepared by mixing concentrated hydrochloric acid and concentrated nitric acid in the ratio 3:1. Aqua is a highly corrosive and fuming liquid. Aqua is a reagent which can dissolve the noble metals like gold and platinum. Now, reaction with salts of other metals. Here, the general reaction is metal A plus salt solution of metal B, giving us salt solution of metal A plus metal B. Here, metal A is more reactive than the metal B, hence metal A replaces metal B from its salt. So what kind of reaction is this? This is the displacement reaction. Here the example is Fe plus CuSO4 giving us FeSO4 plus Cu, that is iron reacting with copper sulfate giving us iron sulfate plus copper. This happens so because iron is more reactive than copper. Now we come to the next part, that is reactivity series of metals. So in the previous slide, we have already discussed that even though metals are reactive, they participate in chemical reactions. The reactivity of each metal is different. So broadly, they are classified as highly reactive metals, moderately reactive metals, less reactive metals, and least reactive metals. So from the diagram itself, it is very much clear that highly reactive metals are potassium, sodium, lithium, and calcium. Moderately reactive metals are magnesium, aluminium, zinc, iron, tin, and lead. Less reactive metals are copper, mercury, and silver, whereas least reactive metal is gold. Next, we come to the reaction of metals with non-metals. A reaction between a metal and non-metal is to attain the electronic configuration of the nearest noble gas with complete octet. So how do they do so? Metals do this by losing electrons, while non-metals do this by gaining electrons. The example is reaction between sodium and chlorine. Sodium is a metal, whereas chlorine is a non-metal. So the balanced chemical equation is 2Na plus Cl2, giving us twice NaCl, which is an ionic compound. Another example is magnesium plus chlorine, that is Mg plus Cl2, giving us MgCl2, which is another ionic compound. The outermost shell of noble gases, like helium, neon, and argon, it is being complete. They are chemically inert. They do not participate in any chemical reaction. So with this, we complete the physical and chemical properties of metals. We will continue the next part of the chapter in the next video.